transmit a super high-vision program using terrestrial waves. First, let us take a look at the large capacity transmission technology used in our prototype system. In addition to ultra-multi-level OFDM technology and dual polarized MIMO technology, which are the subjects of our previous research, our recent prototype system features a new application of bulk transmission using two channels with a bandwidth of 6 MHz in the UHF band. By optimizing transmission parameters, such as increasing FFT size to 32 kilopoints, we are able to greatly increase transmission capacity. We succeeded in transmitting 12 bits of data per carrier symbol by expanding the number of signal points in the carrier modulation scheme to 4,096. Meanwhile, the dual polarized MIMO technology doubles the transmission capacity by simultaneously using horizontally and vertically polarized waves within the same channel to transmit different information. For the first time, we introduced interpolarization, interleaving, that makes the transmission characteristics more robust in an environment in which one polarized wave has deteriorated. Next, let us take a look at the field experiment of super high-vision transmission using two channels with a bandwidth of 6 MHz in the UHF band. First, a compressed-coded super high-vision transport stream was split into two transport streams at the transmission site. The two split transport streams were then inputted into two prototype modulators, respectively, to produce a horizontally and vertically polarized signal from each of the two modulators for a total of 4 signals. The frequency of the 4 modulated signals were then converted to channels 31 and 34 in the UHF band. After the 4 signals were amplified by power amplifiers, multiplexed by an antenna, combiner, and transmitted from a dual polarized antenna mounted on the roof of the NHK STRL building. Meanwhile, at the reception site, one dual polarized Yagi antenna was used to simultaneously receive the horizontally and vertically polarized waves. First, the signals amplified by low-noise amplifiers were converted into intermediate frequency signals using receivers for horizontally and vertically polarized waves. The signals were then demodulated into a transport stream by the prototype demodulators for each channel. Finally, the two transport streams were combined into a single stream using a transport stream multiplexer, and the super high-vision signal was successfully decoded and displayed without error. The success of the recent tests has brought us one step closer to our goal of super high-vision terrestrial broadcasting.